This is part 2. Here's the reaction that's given. 3 carbon plus 4H2 yields C3H8, which is propane. And the question asks, what mass of hydrogen is necessary to react 1 kilogram, 1.0 kilograms of carbon? So we have 1.0 kilograms here, and we want to know what mass of H2 is needed. So we start with our quantity, 1.0 kilograms of carbon, 1 kilogram per 1,000 grams of carbon. Don't forget to do that. And I don't have to calculate a molar mass. It's 12.011 grams of carbon per mole carbon. That's from the periodic table. Now I use my stoichiometric conversion, and I get my numbers from here. It's 3 moles of carbon per 4 moles of hydrogen. So 3 moles of carbon, 4 moles of hydrogen. Go to the next line. I'm going to multiply by, that's H2, excuse me. Very important to get the units right. And then I multiply by 1 mole of H2 per how many grams of H2. So I'm going to have to calculate that. It's really easy. The molar mass of hydrogen atoms is 1.0079 times 2, and that gives us 1.0079 times 2 gives us 2.02, I rounded off, grams of H2 per mole. So I have 2.02 grams of H2 per mole of H2, and I'm done. That's all there is to it. So it's about finding the path. So I take my 1 kilogram, multiply by 1,000, divide by 12.011 times 4, divide by 3 times 2.02, and I get 224.2 grams of H2. And to get it in the right sig figs, I only need 2. This is enough. Conversion factors enough here, and those are infinite. So I have to put it in scientific notation. 2.2 times 10 to the 2 grams of H2. So one question comes up a lot is, how many sig figs to use in the molar mass? And the answer is use enough.